Welcome to Yurix AI. This is Lecture 3 of LLMs from Scratch, Zero to Builder. If you're just starting your journey into artificial intelligence and want to really understand how these massive systems are actually put together, well, you're in the exact right place. Today, we're breaking down a monumental research paper that basically laid the groundwork for modern AI. We'll be focusing on the foundational architecture of large language models. So let's just dive right into it.
Here are our learning objectives for today's explainer. We're going to cover 4 main things. Number 1, the 2 stages. Number 2, pre-training and how it builds broad knowledge. Number 3, fine-tuning and adapting behavior. And finally, number 4, fitting the stages together.
All right, Section 1, the 2 stages. This is the macro view of building an AI brain.
Now, when researchers build models with hundreds of billions of parameters, like the GPT-3 model we're looking at today, it's a highly structured 2-part journey. I want you to anchor your understanding around this one standout idea right now. Pre-training builds knowledge, fine-tuning builds behavior. We're talking about the exact same underlying model here, but it goes through 2 radically different phases of development. This is literally the core mantra for today's lecture. If you keep this in mind, the rest of the complex engineering is going to make perfect sense.
But before we go any further, let's define a crucial term you're going to hear a lot today: corpus. A corpus is simply a massive, diverse collection of text data used to train an AI. For example, the researchers in our source material use datasets like the Common Crawl, which contains nearly 1 trillion words scraped right off the internet. This massive corpus is the raw material the AI learns from. It's the fuel for the whole system.
Moving on to Section 2, Pre-training, Broad Knowledge. This is all about developing pattern recognition.
So let's define what we actually mean here. Pre-training is the initial, unsupervised learning phase where an AI models language from that massive corpus we just talked about. The absolutely crucial keyword here is unsupervised. There aren't humans sitting in there correcting the AI's math or telling it how to be polite. The model is simply reading billions and billions of tokens of text, books, articles, websites, and trying to predict the next word over and over again.
Take a look at how this works in practice. As the model reads these incredibly extensive sequences, it's taking in everything from complex math equations to foreign translations down to just everyday simple sentences. By doing this, it's absorbing general information about how human language works, how facts relate to one another, and how syntax is structured. And it's doing all of this without a specific end task in mind.
The researchers summarize this perfectly. They note that during this phase, a language model develops a broad set of skills and pattern recognition abilities. Think about that for a second. It's not learning how to be a customer service bot or a medical advisor. It's just learning how to be a highly proficient language engine. It's building this immense, incredible foundation of world knowledge.
Next up, Section 3, Fine-tuning, Adapting Behavior. This is where we start specializing the AI.
Once we have this incredibly knowledgeable but kind of undirected model, we need to specialize it. Here's your definition. Fine-tuning is the process of updating a pre-trained model's weights using a supervised dataset for a specific task. Notice the shift. Unlike pre-training, which was completely unsupervised and wild, fine-tuning is highly supervised and highly targeted. We are literally taking the model by the hand and showing it exactly what we want it to do.
You can clearly see this traditional fine-tuning process happening right here. During those orange gradient updates, the model is being fed highly specific examples, like translating English sea animals or candies into French. After every single example, the researchers perform a gradient update. They're actively tweaking the model's internal weights, effectively telling it, yes, that's exactly right, or no, do it more like this instead.
So the really crucial point here is that fine-tuning adapts the model to narrow, desired tasks using thousands and sometimes hundreds of thousands of very specific examples. If pre-training gave the model its vast vocabulary and understanding of physics and history, fine-tuning teaches it to use that knowledge to specifically format a polite email, or translate a legal document, or answer a customer's question without just making things up.
Finally, Section 4, Fitting the Stages Together. Let's synthesize this whole process.
I really want you to walk away with a crystal clear understanding of the whole picture. When we put these 2 phases side by side, the contrast is stark. Pre-training builds knowledge. It's vast, it's unsupervised, it requires massive computing power over months of time, and it relies on a gigantic corpus of 1 trillion words. Fine-tuning, on the flip side, builds behavior. It's narrow, it's supervised, it takes way less time and computing power, and it relies on a carefully curated data set of maybe just a few thousand examples.
To really lock this concept in your brain, let's use an everyday analogy. Think of pre-training like 4 years of college. You're reading broadly, right? History, science, literature, math. You're developing a massive base of general knowledge and critical thinking skills, but you aren't exactly trained for one specific office desk yet. Now, fine-tuning? That's your first week of on-the-job training at your new corporate job. You already have the knowledge from college, but now your boss is supervising you, showing you exactly how to format the company TPS reports and how to reply to clients. You're taking your broad college knowledge and adapting your behavior to a very specific, narrow task.
Okay, let's quickly recap our core takeaways for today's explainer. First, large language models are built in 2 distinct stages. Second, pre-training builds broad knowledge from a vast corpus. That's the college phase. Third, fine-tuning adapts the model's behavior for specific tasks, the on-the-job training. And finally, never forget, it is the exact same model, just passing through 2 critical phases of its evolution.
Before we wrap up, I want to leave you with a rather provocative thought drawn directly from the research paper. The authors actually warn that relying too heavily on fine-tuning with narrow data can cause a model to exploit spurious correlations. So it makes you wonder, could fine-tuning on overly narrow datasets fundamentally limit an AI's ability to generalize outside its training? Are we making them too specialized and maybe losing that beautiful, broad intelligence we worked so hard to build in the pre-training phase? It's a fascinating engineering challenge that AI builders are actively wrestling with today.
I really hope this lecture helped clarify exactly how these incredible models come to life. Like, share, subscribe to Yurix AI for a new lecture every day. Hit the bell.